All right, guys, we're going to go through some energy, wavelength, and frequency calculations here. So first of all, let's remember electrons, what causes them to jump to higher energy levels. So if they're going to go to higher energy levels, they have to be absorbing energy. When they absorb that energy, right, they're able to jump to the higher energy levels. When they fall back down, they have to release energy. Okay? So we have a few different ways that light can interact with matter. What we're going to be focusing on is our electrons jumping energy levels and changing energy levels. So it's electromagnetic radiation, right? It's light waves that our photons are able to either excite our electrons into higher energy levels, or photons getting released. When we release that energy, our electrons going to lower energy levels. So when we think about this, we can see here that a hydrogen absorption spectra, where if we were to have just a hydrogen atom, it would absorb light in five distinct areas within our visible light range, okay? So this is our visible light range, and you can see these black lines are where hydrogen is absorbing that energy, okay? So the lines, the dark lines, show the specific wavelengths of light being absorbed, okay? Now, those same lines you can see line up when hydrogen, after it has been excited, it can release those photons of energy. And so the bright lines here show the specific wavelengths of light being released. Okay, so these lines correspond to energy between our distinct quantized energy levels, okay? So what we can do is we can take these lines, they're colors, right? Colors of light. We can take the wavelength, frequency, and energy and do some calculations with them. So that's what we're going to do down here, okay? So we have two equations that we're going to need to use. The first one here is E equals h nu, and then the second one is C equals lambda nu, okay? So E is our energy, all right? And energy, we always measure it in joules. That's what our big J stands for, okay? H is a constant. This is what's known as Planck's constant, and is equal to 6.626 times 10 to the minus 34th joules seconds. That's a very weird unit, but it really is just a constant number, and it's going to make our units cancel out, okay? The next piece here is nu, and what you'll notice is that nu shows up in both equations, okay? So this is our piece that is going to allow us to go in between these two equations. And nu is the frequency of light. It has units of per second, okay? So if we have something, you know, it's number of photons per second. It's also called hertz, okay? So anytime that we have something per second, right? So beats per second, right? It's hertz, okay? So if you've heard of hertz before, that's oftentimes beats per second that we've maybe heard about before. Over into our second equation here, we have C equals lambda nu. We already talked about nu there, so let's talk about C. C is our speed of light, okay? And that is 3 times 10 to the 8th meters per second, okay? And just like H, it is also a constant, okay? So H is Planck's constant, 6.626 times 10 to the minus 34th joules seconds. Anytime that we see H, we can always put that number in there. Anytime that we see C, it's our speed of light, it's 3 times 10 to the 8th meters per second. We can always put that one in there, okay? The last one here, our wavelength, you can see that this kind of looks like a wave. That is lambda. That's our wavelength. We generally measure our wavelength in meters. However, sometimes we're going to have to transfer our meters to nanometers because our wavelength, as we can see just up above here, our visible light spectrum generally goes from 400 nanometers to 700 nanometers. That's what we can see. And so our nanometers is a relatively convenient unit for us to use. Okay? So what we need to be able to do is we need to be able to take and use these two equations and go from energy to wavelength to frequency, from energy to frequency to wavelength, or back the other way. All right? So we have to be able to use any of those three variables and be able to calculate the other two. So let's go ahead and let's do some practice here. Okay? So here's our first practice question. The question says, an electron drops from the third energy level to the second energy level, releasing a photon with a wavelength of 656 nanometers. What is the frequency and energy of this photon? So when we look at this question, first of all, we notice, okay, energy is being released, right? We're going from the third to the second energy level. We can think about our Bohr diagram again and think about what that would look like. And then we can say, okay, I know that I am releasing a photon with a wavelength of 656 nanometers. And then it asks, what is the frequency and energy of this photon? Okay? So the first thing that we do when we read a question like this, we always need to identify the information that we have. So first, we identify that we have information that is 656 nanometers. That is our wavelength, okay? So if we remember, we go back here, wavelength is our lambda here. So wavelength is lambda, that is our variable that we have, okay? The next thing that we need to do is we need to identify where are we going and what are the equations that we can use, okay? So we need to go to frequency and energy, okay? So when we look at our two equations, we see, okay, I have lambda, I have the wavelength. I need to get to my frequency. How am I going to get to my frequency? Well, I'm going to have to use this equation. That's the equation that has my two variables in it. I know one of the variables, so I can solve for the other. And I'm going to need to rearrange that equation. So that's what I do here. I have C equals lambda nu, and I'm going to rearrange it. When I rearrange it, I have this here. I need to rearrange it and solve for nu. Nu is my frequency. I need to solve for frequency, so I need to solve this equation for frequency. So I divide both sides by lambda. When I do that on this side, these two are going to cancel out, and I'm going to be left with nu on the right-hand side there. So now I can flip-flop it. I'm going to have nu equals C divided by lambda. That's the equation that I have right there. So that's going to give me my frequency. Once I have solved for my frequency, then I can go and I can use my other equation. Once I have frequency, I can go and I can solve for E, my energy. I don't have to rearrange this equation because my equation is already solved for energy. I have H, which is again a constant, and I will have my frequency that I solved in this first equation. Okay? So now let's actually go and let's solve some things. I'm going to go on to the next page. So we need to plug in our numbers. Okay? So the first thing that we do here, we know that we have 656 nanometers. For me to use my equation, I know that I need to line up my units, which means that I need to use meters. Okay? So C is meters per second. So the first thing that I need to do is I need to calculate my wavelength and have that in meters. So I take my 656 nanometers and I'm going to convert nanometers to meters. If I'm going to convert nanometers to meters, I got to put nanometers at the bottom, I put meters at the top, and I use my conversion table to go from nanometers to meters. Put 10 to the negative 9th on top, multiply 656 times 10 to the minus 9th. That gives me 6.56 times 10 to the minus 7th meters. Then I can go over and plug that into my equation. I know C, so C was 3 times 10 to the 8th meters per second. I plug in my 6.56 times 10 to the minus 7th meters. I put that on the bottom of this because I'm dividing. I do 3 times 10 to the 8th divided by 6.56 times 10 to the minus 7th, and I end up with 4.57 times 10 to the minus 14th, or 10 to the 14th, and that is per second. My meters cancels with meters, and I have seconds that are left over on the bottom. That's perfect because my frequency is per second. Finally then, I get to take my energy, or solve for my energy. I use H, Planck's constant, 6.626 times 10 to the minus 34th joules seconds, and I'm going to multiply that by my frequency that I just solved for. Take my frequency, bring it down here. I'm multiplying, so the number goes on top. My per second, the seconds are down at the bottom. Seconds are going to cancel with seconds. I take my numbers and multiply them together. When I multiply those two numbers together, I end up with 3.03 times 10 to the minus 19th joules. Joules are left over there, and that again makes sense because my energy is in joules. So in our next video, we're going to go and we're going to practice a couple of these, okay?